Hello to the demonstration of the measurement of the antenna function of the body, or, if you like, the Vivobase mode of action for protection against electromagnetic radiation. We have created this training video for you so that you can measure the antenna function of the body, or the mode of action of Vivobase itself. For this we need some equipment that we see here on the table in front of us, and I'll explain in more detail later. The devices are an eSmog Spion, in English eSmog Spy device, a digital recording device, a laptop with a software loaded for modeling music files. For this also we need the necessary wiring. In general, it should be said that other devices can be used for the measurement, as long as an integrated body contact antenna is included. The eSmog Spion is a highly sensitive broadband frequency measurement device for the measurement and detection of low or high frequency electromagnetic radiation. The device is able to detect interference frequencies down to the human cell. Since the device is very sensitive, care should always be taken to ensure sufficient grounding of the subjects to be measured in order not to destroy the device by static charge. Let's take a closer look at the device. The device is equipped with different antennas for measuring different measurement scenarios. Furthermore, the device has the opportunity to perform both low frequency and high frequency measurements. For example, there is a digital antenna for measuring radio frequencies. As an example, wireless phones, mobile phone, radio masts, and so forth. The antenna is plugged into the high frequency socket called HF for measurement, and then the device is set at the switch to HF position. On the left side you can see the strength of the radio beams by means of the integrated LEDs. The LEDs are used for coarse visual reading of the radio beams. In addition to the HF and NF sockets, there is also a volume control. Another antenna that is also used for our measurement here in the video is the body contact antenna. This antenna can be used to record interference frequencies in the body as well as ambient radiation. Again, we use the HF socket in our video as an example for high frequency measurements. As already mentioned, there is a volume control next to the jacks. This should not be adjusted during the measurements, but all measurements should be taken with the same volume level. Let's now perform a reference measurement of the ambient radiation in the room. To do this, we connect the eSmog Spion to the audio channel via a cable and a digital recording device. We start the digital recorder and prepare to take the first measurement. Now we switch the eSmog Spion with a slide switch to the HF position with a body contact antenna plugged in and start the digital recording device. With the naked eye you can register no significant change in the LEDs for the frequency level. The reference measurement takes 15 seconds and afterwards we switch off the eSmog Spion again. A subject who has never been in contact with Vivobase is now being prepared for reference measurement. In order not to destroy the eSmog Spion by electrostatic charging, we ground the subject briefly to make sure she is not electrostatically charged. Subsequently, the subject makes contact with the body contact antenna. Only then we will switch on the eSmog Spion for safety reasons and start measuring the rays in the body. Here is already visible with the naked eye, which deflects LED to the highest frequency level. What already means here is that the radiation in the body is much higher than in the environment. Again, we measure for 15 seconds. The subject now received from us for about 1 hour a Vivobase mobile device, which she will carry permanently for the time being. After 1 hour of carrying the Vivobase mobile, another measurement is carried out. Here we proceed in the same sequence as in the first two measurements. First we measure the ambient radiation to show that there are still radiation in the room. The eSmog Spion is turned on and we start the 15-second measurement with the digital recorder. It should always be ensured that you do not move with the body parts over the meter during the measurement, because the human body has an antenna function and thus the measurements can be falsified. We ground the subject again to make sure there is no electrostatic charge. Then we measure the subjects for 15 seconds. Now that we have done 4 measurements, 2 times environmental measurement and 2 times subjects, we turn off the digital recorder and connect it to the laptop. Then we switch the digital recorder back on and transfer the 4 measurements to the laptop. For this we use our software Wavelabs Elements 9.5 from the company Steinberg. You can use any other software which is capable to manage music files as well. Once the software is open, we search for the digital recorder in the file browser. The device has the designation DR-05 in this example. In our example you will find the 4 saved files under the folder Music and the folder Test1. The downloaded files, in this case the file with the extension 70, refers to the first environment reference. The file with the ending 71 refers to the first measurement on the subject without Vivobase. The file with the ending 72 is the new environmental reference after 1 hour, and the file with the ending 73 is finally the measurement on the subject after wearing Vivobase for 1 hour. The next step is to create a file in which the saved 4 measurements are inserted so that the respective measurements are inserted in the correct order. We start with the file with the ending 70 and then insert the following files afterwards. Between the individual insert steps, the files thus insert are released by the key Escape, so that you can easily insert the next file. As soon as all files are inserted in the still nameless file, you are now able to visualize the 4 previously inserted files via the Show item and the 3D frequency analysis button. For the resolution of the representation, we use the setting highest frequency to 20,000 Hz, lowest frequency set to 20 Hz, logarithmic ruler, and amplitude equal linear. The displayed 3D diagram on the x-axis, read from the right to the left, is representing the time in seconds, and on the epsilon axis, read the measured frequency strength from top to bottom. As an example, the light blue line shows the frequency of a wireless phone in the range of 1.4 kHz. Looking at the diagram from right to left, the first 15 seconds shown there are the first environment measurement. The following 15 seconds show the measurement of the frequency in the body of the subject without Vivobase influence, which shows a significant upward swing over the previously measured ambient radiation. This is a clear evidence of the antenna function of the body due to the fact that living beings are mostly built out of water. Water is an information carrier. Frequencies are information and are greatly enhanced in the body. The measurement after 30 seconds showed a renewed environmental radiation measurement after 1 hour carrying Vivobase, which served to provide evidence that the ambient radiation in the room, as in the first measurement, is still existent. The last measurement now shows the antenna function of the subject after wearing Vivobase of 1 hour. Here it is clear that the strength of the antenna function has decreased significantly, which indicates that Vivobase technology protects the body against penetration of ambient rays, and the still present rays are slowly reduced from the body. That was the measurement of the antenna function. We are confident that this video will give you the support you need to give you a safe way to prove the power of Vivobase. If you have further questions, you can reach us via the known contact options. Thank you very much for your attention.